Hello everyone. To help you in your self-study of permutations and combinations, I want to give you three examples that are based on past IB questions for you to see what kind of problems you may encounter during your exams. We're going to start with the problem you can see in the screens. Mary, three female friends, and her brother Peter attend the theater. In the theater, there is a row of 10 empty seats. For the first half of the show, they decide to sit next to each other on this row. A. Find the number of ways these five people can be seated in this row. To answer this question, you want to picture the 10 seats and then see how the group of 5 people all together can sit on the row. So depending on where the first person starts sitting, you're going to have a different arrangement for sitting. So you can see that there's only a total of 6 arrangements that you can, or 6 different ways that you can sit together with your group in the row. So we're going to start by writing that down. So the number of times, it will be 6 times. And then we need to multiply by how many ways you can seat the 5 people in those 5 seats that are being used. 5 people in 5 seats, that is a 5 factorial, which is 720 different ways. Now for part B, it says, for the second half of the show, they return to the same row of 10 empty seats. The 4 girls decide to sit at least 1 seat apart from Peter. The 4 girls do not have to sit next to each other. B. Find the number of ways these 5 people can now be seated in this row. There are 2 cases in this situation. The first case is when Peter takes a seat on either end of the row. We are guaranteeing that at least one empty space is left so that nobody sits around him. That means we leave for the girls 8 seats to choose from. So their arrangement in that case is going to be 8 permutation 4, because the order in which they're sitting matters. So it would be a permutation rather than a combination. And then we know that Peter can sit in 2 different ways. And we know that the girls can sit in 4 factorial different ways once they have chosen their seats. Now the second scenario is when Peter is not seated at the end or at the start of the row, but he's going to be in somewhere in the middle. Now the girls are free to choose any seat on that row that is not next to Peter. So this leaves actually 7 seats for the girls to choose from, and that would mean they can choose 7 permutation 4 ways to sit. Now, Peter has a total of 8 possibilities to sit, so he has 8 options. And the girls, once they have selected their 4 seats, they have 4 factorial ways to sit. Now, these 2 scenarios need to be added, so this should give us a total of, so this is going to be, the first one is 3,360, and the second one is 6,720. This gives you a total of 10,080 different ways. Let's move on to problem number 2. Example 2 says, consider the set of 6-digit positive integers that can be formed with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Find the total number of 6-digit positive integers that can be formed such that the digits are distinct. So if we think, say, similar situation, instead of chairs, we have digits in a number, and we only have 6 of them, right? We know that the first digit, if it's a 6-digit number, the first digit cannot be 0. It has to be different from 0. So we actually only have 9 options for the first number. Now for the second number, we have, since we already used one of the numbers, we have only 9 options left. since we already used 2, for the next number we have 8, for the next one we have 7, we have 6, we have 5. This is equivalent to calculating it this way. The first 9 is non-debatable, it cannot be 0, and then it leaves us with 5 other spaces to fill in, and we're going to fill it where we can't repeat the numbers, so we have 9 numbers left, permutation, 5 spaces to fill in. So this should give us 136,080 different ways. Now for part B, it says the digits are distinct and they are increasing in order. So for part B, you want to consider you still have 6 digits. Once again, for this number, we know that the digit cannot start with 0, and even going a little bit further, 0 cannot be in any other digit, otherwise the digits are not going to be in increasing order. So that leaves 0 out, and we are only counting with 9 numbers to form this digit. Now what is important in this situation is that the only thing that matters is that we choose 6 different numbers out of the 9 that we have available. So that way, the number of ways that we can choose the digits would be 9 combination 6. And now, in how many ways can we organize those 6 numbers that we chose in ascending order? There's only going to be one way, which means that we can make a total of 84 different ways, or 84 different 6-digit numbers. In the final example, we have 8 runners compete in a race where there are no tied finishes. Andrea and Jack are 2 of the 8 competitors in this race. Find the total number of possible ways in which the 8 runners can finish if Jack finishes A in the position immediately after Andrea. So if we're assuming that Andrea is finishing first and then Jack is finishing second, then we have this situation. They have to be together like this. And to put them together like this, we can put them in different options. We have actually 7 options for them to be together. And then we have to fill in the remaining 6 slots with the other runners. So that would mean they can be filled in 6 factorial different ways. So this would be equal to 5,040 different ways. Now for part B, it says find the total number of possible ways in which the 8 runners can finish if Jack finishes in any position after Andrea. This part of the question can be very easily solved if we think that there is an equal number of ways in which Jack will finish before Andrea and Jack will finish after Andrea. So if we think about it, the 8 runners will finish in 8 factorial different ways. Half of those ways, Andrea will finish first, and in the other half, Jack will finish first. So actually, we need to divide by 2 to find the exact number of ways in which Jack is going to be behind Andrea. And this gives us 20,160 different ways. Now, I hope that these 3 examples have been useful to you. The questions in IB, they are so varied that these are just a small sample of anything you can be asked during one exam. So I continue to encourage you to look for additional problems in your textbook, in past papers, different videos on the internet where they do solve examples, and try to do those by yourselves and practice, of course.